morning, students. I'm Visweswara Rao Sir. Today, I'm starting a new series that is solving of NCERT problems, useful for students appearing for NEET examination, JEE mains and advanced and board examinations. This is the first class in the organic chemistry. And in this class, I'm giving how to find hybridization of a carbon. It's a starting class. That means it's a beginning. If you see carbon electronic configuration, outermost electronic configuration, 2s2, 2px1, 2py1. 2pz orbital is empty. This is the ground state electronic configuration of carbon. In the ground state, carbon is having only two single electrons. It can form only two bonds. But carbon is well known to form four bonds. That's why we have to take a first excited state of carbon. In the first excited state of carbon, this s orbital electron get promoted from s orbital to p orbital. That means the s orbital electron is promoted to p orbital. That is the first excited state. So this is the 2s1, 2px1, 2py1, and 2pz1. Now come to the hybridization. If s orbital, all the three p orbitals participate in hybridization, that is nothing but sp3 hybridization. In the sp3 hybridization, carbon is having four single electrons in four hybrid orbitals. Carbon can form four sigma bonds using these single electrons. There will be no pi bond. On the geometry, tetrahedral geometry with the bond angle 109.5 degrees approximately. If a carbon is undergoing sp2 hybridization, one s orbital, two p orbital, that is sp2 hybridization, it can form three sigma bonds using three hybrid orbitals having single electrons. But one p orbital is not coming into hybridization. One p orbital is not coming into hybridization, means using this p orbital, it can form pi bond. So, in the sp2 hybridization, it is forming three sigma bonds and one pi bond. Now, coming to the sp hybridization. So, sp hybridization means one s orbital, one p orbital. One s orbital, one p orbital means two atomic orbitals are participating in hybridization. You will get two hybrid orbitals. Using these two hybrid orbitals having single electrons, it can form two sigma bonds. But these two p atomic orbitals are not coming into hybridization. Using these two p atomic orbitals, carbon can form two pi bonds. So sp hybridization means it is forming two sigma bonds. Carbon is forming two pi bonds. So whenever you see carbon forming four sigma bonds, no pi bonds. Four sigma bonds, no pi bonds. The hybridization of carbon is four sigma bonds, no pi bond. Hybridization of carbon is sp3. If a carbon is forming three sigma bonds and one pi bond, its hybridization is sp2. Carbon is forming two sigma bonds and two pi bonds. Its hybridization is sp. So this is that means so you follow this thing to identify the hybridization. Geometries also. sp3 hybridization means tetrahedral bond angle 109.5 degrees. sp2 hybridization means a planar triangle bond angle is 120 degrees. sp means it's a linear structure with a bond angle 180 degrees. You can also find the geometries based on this hybridization. Now, these questions I taken from NCERT, solved and unsolved. Okay. For example, you see first one CH3Cl, very straightforward. Carbon is forming four sigma bonds. The hybridization of carbon is sp3. That's all. That is your answer. Now come to the B question. CH3 twice CO. So I'm writing the expanded structure. C double bond O, this is CH3 and this is CH3. This compound is acetone. So 3 different carbons are there. This carbon forming all sigma bonds, no pi bonds. Its hybridization is sp3. This carbon forming only sigma bonds, no pi bond. Its hybridization is sp3. This carbon is forming 3 sigma bonds. So see, this is the double bond. Double bond means 1 sigma bond, 1 pi bond. This is sigma, this is sigma. Carbon is forming 3 sigma bonds, 1 pi bond. The hybridization is sp2. Now come to this one. CH3Cn. CH3Cn means I will write the structure of cyno group here, that is a functional group cyno group, C triple bond here. So nitrogen, after forming 3 bonds, it will have 1 lone pair. Now come to this carbon. This carbon is forming 4 sigma bond, 3 hydrogens and 1 this one. And its hybridization is nothing but sp3. This fellow, this carbon is forming triple bond. Triple bond means 1 sigma, 2 pi bonds. So this carbon is forming 2 sigma bonds and 2 pi bond. 2 sigma bond, 2 pi bond means hybridization is sp. So it is sp. And that's what actually we are doing. But sometimes paper setters may also ask Visweswara Rao, what is the hybridization of nitrogen? They can also ask that one. So nitrogen is also, that means in this case nitrogen. So in a way, you can write the electronic configuration of nitrogen 2s2, 2px1, 2py1, 2pz1. And you see, even without writing electronic configuration also, you can do like this. Nitrogen, to keep lone pair, it needs 1 hybrid orbital. To form 1 sigma bond, it needs 1 hybrid orbital. So nitrogen, for the lone pair, 1 sigma bond, it needs 2 hybrid orbitals. So 2 hybrid orbitals means it is undergoing sp hybridization. Using this fellow, it can form 2 pi bonds. So the hybridization of nitrogen in this case is sp. The lone pair on the nitrogen is present in the sp hybrid orbital. I'm simply writing HO. HO means hybrid orbital. So they may ask like that. Sometimes that means you are supposed to identify the hybridization of nitrogen in the aromatic compounds later on also. So now come to the next one. This is what they given, HO and H2. HO and H2. HO and H2 is called, that is the hydroxylamine. This is nothing but HO and H2. That means here the carbon is not there. So you can go for the nitrogen hybridization and oxygen hybridization if you want. Nitrogen same here. See, nitrogen is forming 3 sigma bonds here. It is having 1 lone pair. 1 lone pair. So 3 sigma bonds, it needs 3 hybrid orbitals. To keep 1 lone pair, it needs a 4th one. So definitely it is undergoing sp3 hybridization. What about the oxygen here? Oxygen is forming 2 sigma bonds. For 2 sigma bonds, it needs 2 hybrid orbital. To keep the lone pair, 2 lone pairs, it needs 2 more hybrid orbital. So oxygen is also undergoing sp3 hybridization. In all these cases, lone pairs are present in sp3 hybrid orbitals. So now I'm coming to the next compound. This is our next compound here. So CH2 double bond O. So CH2 double bond O meant that is a well-known compound that is called as formaldehyde. In the examination, paper setter may also give names. This is what is the hybridization of carbon in formaldehyde. Then we are supposed to write the formaldehyde structure. Then you have to identify the hybridization. In this case, it is straightforward. Carbon forming 3 sigma bond, 1 sigma bond, number 2, number 3. It is also forming pi bond. So 3 sigma bonds, 1 pi bond meant 3 sigma bonds. It needs 3 hybrid orbitals, and that is sp2. And oxygen, I'm not bothering now at this point of time. CH3F, I don't, that means I don't, I'm not explaining that one. You can easily answer that question. And this is also C triple bond N, I already explained. You can also answer that question. all by yourself. So now coming to this one, that means this fellow. So what is this one? This is a really important example, and many students are doing a mistake in this case. Carbon is forming 3 sigma bond. 2 hydrogens are connected here, 1 sigma bond. It is definitely sp2 hybridization. And this carbon, and students are generally having a tendency after solving many things, many problems on the hybridization, they're having one tendency. They see double bonded carbon, immediately they identify as sp2 carbon. If they see triple bonded carbon, immediately they identify that one as sp carbon. They see all sigma bonds carbon, that means they identify that one as sp3 carbon. That is correct only, no wrong with that. But this concept leads to sometimes, that means doing the problems in this way sometimes leads to wrong conclusions. For example, you are seeing double bonded carbon. If you identify this one sp2, that is not correct. So that's why I'm strongly suggesting don't do the problems in this way. Always count the number of sigma bonds, number of pi bonds that carbon is forming. Then you can, this carbon you see it is forming 2 sigma bonds here and 2 pi bonds. For the formation of 2 sigma bonds, it needs 2 HOs. For the formation of 2 pi bonds, it needs 2 p orbitals. So the hybridization of carbon in this case is sp, it is not sp2. So don't go that way. Double bonded carbon is always sp2. No, not like that. Always count the number of sigma bonds and pi bonds. Now, these are 2 more examples given in the NCERT textbook. I think you can easily solve this problem. This also, that means cyano group I just solved here. Anyway, I'm writing this one, double bond CH, and this is C triple bond N. And this carbon forming 1 pi bond sp2, carbon forming 1 pi bond sp2, this carbon forming 2 pi bonds sp. Like that also you can answer the question. And one more thing, that is nothing but benzene ring. Benzene ring is, you see, this is the benzene ring here. I'm writing, everybody know what is benzene ring, but I'm writing the Kekulé structure here. This is the Kekulé structure of the benzene rings. This is nothing but one of the Kekulé structure. Once you see, every carbon is forming 1 pi bond. So this carbon forming 3 sigma bond, 1 pi bond, like where, everywhere, like that. That means all carbons in benzene are sp2 hybridized. So these are the questions given in the NCERT on hybridization. So I have seen so many questions in the competitive examination from the hybridization side. But sometimes papers that will ask you, for example, you say, this is sp2 carbon, this is sp carbon. They will ask about this sigma bond. This is sigma bond. This sigma bond is formed by overlapping of what hybrid orbitals. So because this carbon is sp2 and this carbon is sp, that sigma bond is formed by overlapping of sp2 and sp hybrid orbitals. Like that also they will, in this way also they can ask the questions now. Sometimes they will ask the bond lengths also, bond strengths also. And of course, carbon-carbon triple bond is short bond. That means if you take the bond length, and no need to by heart the bond length values, those are also very simple. Carbon-carbon bond is carbon-carbon triple bond is shorter compared to the carbon-carbon double bond compared to the carbon-carbon single bond. So this is the shortest bond, and this is nothing but longest bond. Now, if you compare the bond strengths, that means this is the bond strength I am comparing here. Carbon-carbon triple bond is stronger, shorter bond is stronger compared to the carbon-carbon double bond and carbon-carbon single bond. That's all, Nana. So this is the first class in the solving of NCERT problems for the students. This is organic chemistry. Thank you for listening, and you can watch the next class in the next video. Thank you, Nana. Thank you for listening.